Okay, linear and nonlinear functions. A linear graph, if you graphed it, you would have one straight line. And if you looked at it in a table, there would be a constant rate of change. A nonlinear graph, when you graph it, does not make a straight line. So it either has a curve, or it has a break in the line, or a bend in the line somewhere. And that does not have a constant rate of change. Alright, so here's a table. Does the table represent a linear or nonlinear function? And then explain. So I'm going to look to find patterns in this table. So if I look at the x's are on here, on the top. If I look across, I go from 3 to 6. So that was plus 3. If I go from 6 to 9, that's plus 3. And 9 to 12 is plus 3. So that's a constant rate of change for the x. Now I need to see if I have a constant rate of change for the y. Well, I went from 40 to 32, so it's decreasing by 8. 32 to 24, decreasing by 8. 24 to 16, decreasing by 8. So I have a constant rate of change for my x and a constant rate of change for my y. So as x increases by 3, y decreases by 8. The rate of change is constant. Therefore, the function is linear. Does the table represent a linear or nonlinear function? Explain. So in this example, I'm looking for a pattern. So 1 to 3 plus 2, 3 to 5 is plus 2, and 5 to 7 is plus 2. That's a constant rate of change for x. Now I need to see about y. Well, 2 to 11 is plus 9, 11 to 33 is plus 22, and 33 to 88 is plus 55. So that would not be a constant rate of change. You could also check to see if it's changing by multiplying by the same number. If that's the case, if it's the same each time, then that would still count, even if it's not addition. So, as x increases by 2, y increases by a different amount each time. Therefore, the rate of change is not constant, and the function is nonlinear. Does the graph represent a linear or nonlinear function? So, if the graph makes a straight line, it's linear. If it's not straight, it's nonlinear. This graph has a curve in it, so it is nonlinear because the graph is not a line. This graph has a straight line, it's a horizontal line, through y equals negative 2. Because it's a straight line, the graph is linear. Okay, pause and try these. Does the table or graph represent a linear or nonlinear function? Alright, if you look at the table, we're looking for patterns. So from 0 to 7, that would be plus 7. 7 to 14, plus 7. 14 to 21, plus 7. So the x has a constant rate of change. Now for the y. 25 to 20, it's decreasing, so minus 5. 20 to 15, minus 5. 15 to 10, minus 5. So because it has a constant rate of change for the x and the y, that is linear. This graph is not one straight line. It has a bend in the line. So it's going up, then it started going down. So because it has a bend, it's not a straight line. It is non-linear. Alright, which equation represents a non-linear function? Well, if an equation can be written in slope-intercept form, which is y equals mx plus b, it might be missing the mx, it might be missing the b if m is 0 or b is 0. But if it can be written in some sort of form, y equals mx plus b, it's linear. If you cannot write it in slope-intercept form, it is nonlinear. Some giveaways. If you notice that you're dividing by a variable, x, or some other letter, then it's going to be nonlinear. Or if you notice that you have a variable that's raised to a power, it's going to be nonlinear. So, in this example, y equals 4.7, well, you could have 0x, which would cancel out the x, plus 4.7, so that could be written in slope-intercept form if m was 0. In this case, if m is pi and b is 0, it could be written in y equals mx plus b form. This one, I'm dividing by a variable, so that should be a giveaway that it's nonlinear. And this one, if I distributed, I would have y equals 4x minus 4, or plus negative 4, which is in slope-intercept form. Account A earns simple interest. Account B earns compound interest. The table shows the balance for 5 years. Graph the data and compare. So they gave you all this information in the table. Account A started at $100, then it went to $110, $120, $130, $140, $150. Account B started at $100, went up to $110, then $121, $133.10, $146.41, $160, $105. So compounding interest is actually going to earn you more money. So it's saying from here you earn money, now from where you started to now earns money. If you made a graph, you would see, hopefully you would notice that account A has a straight line and account B has more of a curved line. That means that account A is linear and account B is nonlinear. And if you look at A, the rate of change is constant. It stays the same. Every single time the account is increasing by $10. So each year they earn $10 more than last year. But with account B, you're earning $10 or more each year.